All right, kiddos, so today we're talking about light reflection. So we talked a little bit about energy reflecting yesterday and kind of using reflections to direct like waves. We talked a little bit about that, but we're going to get deeper into reflections specifically with mirrors today. So have you ever heard the concept of like using a magnifying glass to set a blade of grass on fire or things like that? Those kinds of things all are done with reflection. So there used to be this thing that was explored on Mythbusters. I don't know if you've seen Mythbusters, but they're hilarious. But there was this Greek scientist who supposedly was able to defeat a lot of his enemies because he would have all the members of his crew reflect surfaces and aim their reflections at the enemy ship, and it would catch the ship on fire before the battle ever started. And so the question then becomes, what makes a reflection more intense and less intense? Because we know that things are not constantly catching on fire from reflections. So we're going to explore a little bit today the different ways that light is reflected and how that varies depending on the surface. So we have like three different things that can happen when light encounters an object. And so it's either going to have transmission, reflection, or absorption. It's going to absorb. So we've got three different options. So for example, like when you're standing on the side of a pond and you can see fish in the water, that's transmission. You're going straight through. The light is shining through the water into things that are underneath the surface. When you have reflection, you're going to think of things like being able to see yourself in a spoon or in a silverware or glass. Those are going to be reflections. And then absorption would be like, let's say you're playing on the pavement in the summertime and that black pavement gets really, really hot in the summertime, right? And that's because that's absorbing the light. So those are the three different things that can happen when light hits an object. So the surface that the light hits really changes how the reflection happens. So if we're talking about a smooth surface, the light is going to hit and then bounce off of it at the exact same angle. It's going to make like a little V. It's going to have the exact same angle bouncing off, and every light that's hitting it is going to bounce off exactly parallel. So it's very precise. But let's say you have light bouncing on like a rough carpet. Your light is hitting at different surfaces. It could be hitting at this angle, it could be hitting at this angle, it could be hitting at this angle. And so it's still going to bounce off with the exact same angle, but because the light is all hitting the surface at different points, those angles are going everywhere. It's very unpredictable. So we're going to get into a little bit more of how some of that is impacted. So what we do when we're looking at the angles is we look at the angle of incidence. So that's when the light is first coming towards the surface. That's the angle of incidence, and it's going to match the angle of reflection. They're going to be the same. But a lot of objects do absorb some light or scatter light, and those are going to be when you're looking at those rough surfaces. That's actually called a diffused reflection, and it usually allows us to see objects around us better. So, for example, if you have sun coming in through the window and that light is reflecting off of your hardwood floors or your carpet, the room seems lighter, right? It scatters that light around the room because it's hitting that surface in different ways, and that's reflecting off in different directions. Even things that seem smooth are not going to reflect light the same way as like a flat mirror. Like even the walls at your house, they may seem very smooth, but if you feel them, they have a texture to them, right? And that texture is going to change the way that light is reflected. Even the smallest roughness on a surface is going to make the reflection less precise. So So we can use the reflections to soften light, but we can also use it to amplify it. So that gets used a lot of times when we're looking at light bulbs, especially in areas like spotlights or lighthouses. We use reflection to make the light point in one more specific direction versus being scattered about. So that's when we really get into the different types of mirrors that we can use when we're coming to talk about reflection. So if we have a plain glass mirror, it's going to hit and reflect directly, right? That incidence angle and the reflection angle are going to be the same. And so that's why when we look in a mirror, we can see our reflection, and it's all directed parallelly, right? They're all parallel hitting and parallel reflecting. That's called specular reflection when that happens. But we can also, not only does the smoothness impact reflection, but so does the shape of the thing. So let's say we're talking mirrors here. So we have two different types outside of just flat. We can have concave or we can have convex. So each one has kind of a unique property and are used for different things. So again, like if you're looking at your reflection, you're using a flat mirror. That's going to be found at like beauty salons or your haircut place or all those kinds of places. And it's able to reflect the image without distorting it at all. You see it exactly how it is. But when we start looking at concave mirrors, we're looking at a different type of reflection. So when you're thinking of concave mirrors, think about the shape at like the end of a spoon, or on the inside of a bowl. So you're talking about kind of that roundish, that dent in, right? We're looking at that kind of shape. So concave mirrors are also sometimes called converging mirrors, because what's happening when you have this round shape, the lights are hitting it, and when they're reflecting, they're actually going to cross each other, right? They're going to end up hitting at all these different points, and they're going to end up kind of crossing each other in this little bowl shape that they're hitting off of. So those things, they really direct light beams when they do that. And so that's often when we do things such as like headlamps and lighthouses. Those are using concave reflections to be able to really point the light in one direction. They use them in solar power, which we've talked about in these last few weeks. So it just is another way to kind of gain more of that sun's energy because you're directing it more into one area, so it's more intense. They also sometimes are used in telescopes, so that's another kind of useful thing to know. But the convex mirror is going to be shaped like the bottom of, a spoon. And so it's actually going to reflect light away. And so they're going to be hitting and then coming out, right? They're going to go out in further directions. So the best way I can think about this is to like give you an example is when you think about the classrooms in Marquette, especially the EC classrooms, but we even still have it in our own classroom because they never took it down. So they have had those row of cubbies, right? And so they have convex mirrors hanging up right by those cubbies because the teachers could see the reflection and it would give them a wider view so they could see everything that was happening on the back side of those cubbies. Those kinds of mirrors are used a lot in grocery stores so that people can help see around corners and see that people aren't stealing or to help discourage people from taking things. So convex mirrors are really going to be things that you're using to get a wider view of an area that you normally wouldn't be able to see. So those are some things to keep in mind. And I think we are at our key points. So the different types of mirrors, you're looking at convex, concave, and flat. A concave mirror is going to direct the light. A convex mirror is going to give you a wider view of things because it's putting light in different directions. And a flat mirror is going to give you a direct image, a mirror image. And then how does the surface affect it? If it's straight and flat and smooth, we're going to be able to really predict where the light is going. However, if it's really rough and bumpy, that light's going everywhere, and we're not going to really be able to predict how that happens. And you also can end up with some absorption depending on the material, as well as some transmission depending on the material of the object. So I think that's it. I hope that helped.